Hi everyone. Today we're going to go over the Quartus software. We're going to design a circuit using schematic designs. We're also going to simulate it using waveform simulation in Quartus, and finally program a DE-10 standard FPGA. So let's go ahead and launch Quartus. While that is launching, I have timecodes down below in the description, so you can simply jump to a section if you don't want to sit through the whole thing. So to get started, let's go over the new project wizard. So you'd click new project wizard here, or simply go to file and new project wizard. Also, quick note, if you don't have Quartus installed, I have guides down in the description as well. I go over installation of Quartus and ModelSim. So go ahead and click next. The working directory by default is actually a read-only directory, so you won't actually be able to go ahead and change this unless you were to manually change the properties of this workspace. So what we're going to do is simply use a different directory. In my case, I've set one up for this exercise, which I'm going to use and paste right in. You can also use the three dots, which I will, and select your folder. I will create a new folder inside this one and call it example, so that all my files are localized to this folder for this project. I will also name my project example just to be consistent, and then click next. The project type we're going to select as empty project because we don't have any other files or settings that we want to import from. So go ahead and click next. Same goes for files. We're starting from scratch, so we don't have any, and just click next. The family device and board settings are quite important because the DE-10 standard FPGA is part of the Cyclone 5 SoC family. So if you don't see Cyclone 5 under family, that means you didn't install the board package for Cyclone 5, or you messed up your installation somehow. In either case, you'd want to make sure you have the support package or reinstall Quartus with the support package. Let's go ahead and also add the device name. The DE-10 standard comes with this specific FPGA device, so I'm going to paste that in. It'll also be down in the description. So go ahead and select it, then click next. For simulation settings, since I installed this with QuestaSim, it defaults to Questa, but for the purpose of this demo, we're going to actually go ahead and set this to none. That'll be important in a second. Usually by default, I actually like to use ModelSim and Verilog, but for now, I'm going to go ahead and click none. Then click next, which will take us to the summary. This is just an overview of all the settings we've had so far, so just go ahead and click finish. Great. One thing I like to do once I'm in here is go to the project navigator and switch from hierarchy view to files. And that'll be important just in a minute once we add some files in. So let's go ahead and create our first schematic. So click on file, new, and then once you're here, you'd want to choose block diagram or schematic file and click OK. Once you're here, you should see some grid lines. If you don't see the grid lines, you can go ahead and click view and choose show grid lines. You can also zoom in by either pressing down Control and using your scroll wheel to zoom in, or you can use the zoom tool to zoom in into a selected area. I'm just gonna zoom out a tad bit and hit escape. Let's go ahead and add some gates. In this case, I'm going to use the symbol tool to add my gates. You'd actually want to expand this so we'd actually see all the possible gates. Expand primitives, expand logic, and then if I scroll down, I can see the 2-input AND gate, which is what I'd like to use, and click OK. And then we'd simply place this down. Since it's in repeat mode, every time I press, it's going to place one down. I only need one, so I'm going to hit escape, and then press delete. Let's go ahead and add a 2-input OR gate. So again, click on the symbol tool. This time I'm just going to type it in, OR 2. Again, see, repeat mode's checked, so let's go ahead and click OK, place it down, and then just press escape. I'm also going to add 2 NOT gates, so type in NOT. These are inverters, and I'm going to place them just so. And hit escape. Let's go ahead and add our input pins. So input, press enter. Okay, move this up. You can also scroll horizontally by pressing down Shift and using your scroll wheel. And then if you were to use it without pressing anything, it'd just scroll vertically. So let's go ahead and add our output pins. Place one for each inverter and then one for each standard gate, and hit escape. I'm going to zoom out a little bit and start wiring things up. So let's go ahead and add some wires. For that, you'd want to use the orthogonal node tool. We're not going to worry about these other tools right now since we're dealing with single wires. So go ahead and left click over the starting point, and once you see a box, you can go ahead and release. And that would create a connection between these 2 nodes. So I'm just going to go ahead and do that for all these gates right here. Output. Just so. There we go. And then I will hit escape. Now, at this point, we can go ahead and save our design. There's some more changes that we have to do, but just so that it's saved, let's go and click File, Save. You can also click Control S. I'm going to rename this to Gates. It's by default a BDF, that's what we chose. You also want to make sure that Add File to Current Project is selected, and then click Save. If you see, our file now shows up under Files. Now, one of the reasons I actually had chosen to switch to Project Navigator to Files instead of Hierarchy is because if I were to go back to Hierarchy, you'd see that the top level entity is set to Example. So if I were to compile it right now, we'd actually get a failure because there is no file named Example in this project, or entity even. So let's go back. Let's go back to Files, click on Gates, right click, set as the top level entity. And now if I check Hierarchy, it's actually selecting Gates, which is correct. And this file would now compile. But before we compile successfully, let's go ahead and edit the pin names so that it's just easier for us to find these nodes when we're simulating within Quartus. So there's a few ways you can actually do this. To edit pin names, you can click on one, right click, and go to Properties, where I can now set the pin name. This is not the way I like to go. So I'm going to hit cancel. You can simply double click even to get the pin properties. Again, I don't like this, so click cancel. What I like to do is simply double click pin name, and it lets me rename that pin. The reason I like this so much is I'm going to go ahead and name it and_input 1 and press enter, which takes me down to the next input. So we're going to do this for all. Now, the reason I'm using _input or any such extensions is because by default, if I were to say and or use NAND, the simulation or synthesis would disagree. And that's because these are names, as you can see, and2 is all caps, are secured names. So let's restrain ourselves from using these. So I'm just gonna go ahead and do OR input 1, because it does cause conflict when synthesizing. We're gonna do the exact same thing for our output pins. So double click, output, oops, this is our AND output. And then NOR output. Great. So now let's go ahead and synthesize this. You can click the play button or use the hotkey, which is Control+L, or you could go to processing and start compilation. Since we modified our design, we want to save our changes and say yes. While this is compiling, let's go ahead and quickly edit some settings before we simulate stuff. Like I mentioned earlier, we're using Model Sim for our simulations, not Questa, because Questa Sim requires a license. So we'd want to refrain from using that. So what I'm going to do is go to Tools and come down to Options, and then go to EDA Tool Options. For me, this is already defined, which might be the case for you. I'm going to go ahead and delete that. And if Model Sim isn't installed or isn't added to the path, go ahead and click the 3 dots. In my case, it was located at this location because I installed it with the standard Intel FPGA as opposed to, Model Sim, or sorry, instead of Quartus, because if I were to go to my C disk, you'd see Intel FPGA Lite, and these are the 2 Quartus models, or 2 Quartus versions I have installed. So go back, Intel FPGA, go to that version, choose Model Sim, scroll down until you see Windows 32, double click that, and just say select folder. And you're good to go. So I'm just going to click OK. Our design also synthesized successfully, so we can actually now go ahead and test it out by simulating it. So to simulate, go ahead and click File, go to New, select University Program Waveform File. That's what VWF stands for. Click OK. Now, another thing I like to do inside here is go to Edit, set End Time, and I'm going to change that to, I'm going to say about 50 nanoseconds. Click OK. Now let's go ahead and add our nodes. So go to Edit, Insert Node or Bus. Click on the node finder and then press list, and this should list all nodes that were synthesized with. There we go. So I'm going to hold down Shift to actually select multiple and use this to copy to the selected node list. The reason I did that is keep in mind the selected nodes show up in the bar over here in the column in the order that you select them in. So that's one of the reasons I'm going to manually select in the order I'd like to see them show up. Now I'm going to go ahead and click OK. OK again. And as you can see, I have my inputs at the top, followed by my AND and NAND. Same for my OR and my NOR. What we're going to do now is we're going to add some signals. Since right now everything is set to 0, it means the default is low. So I'm going to go ahead and select this and force it to high. We're not going to worry about Z or weak low or weak high. These are other standard logic values. I'm going to then switch this to 1. And then simply do the other 2. Oops. There we go. Now I'm going to do the exact same for my OR gates. So we're going to do 0, 0, 0 1 1 0, and finally 1 1. Now let's go ahead and click File and Save to save our waveform file. I'm just going to leave it as waveform. You can rename it if you want, but I'd recommend just leaving it as it is, and click Save. Another thing we have to do before we simulate this is go to Simulation, Simulation Settings, and I'm going to switch over to VHDL since we're using VHDL for this exercise, and remove the No P-opt flag just around there, and press backspace until it's gone. Now I'm going to click Save. We won't worry about timing simulation since the Cyclone 5 boards do not support timing simulations. So now we can actually save it again, because if you see, it's been edited. So File, Save. Now let's go ahead and run our simulation. You can run it by the functional simulation button right here, or click Simulation, Run Functional Simulation. So if you see, it's now using Model Sim, and it simulated it right here. So if we look closely, this replicates the truth tables for both the gates. The signal for our AND gate is high when input 1 and 2 are high, but low for all other cases. The NAND is always high up until both signals are set to 1, then it goes back to low. Same goes for our OR. Our OR is low when both signals are low, high when either signal is high, and our NOR is high when both signals are low, and it is low when either signal is high. So that goes ahead and tells me that my circuit design was correct and everything worked out fine. I'm going to go ahead and now close this. Now we're actually going to make some changes because we'd want to program this on the DE-10 board, and we'd actually like to use actual switches and LEDs. So what I'm going to do is I'm going to first go to Assignments, go to the Assignment Editor, and if you see, there's no pins right now. So what we'll do is go back to Assignments, go to Import Assignments, and it's going to ask us for a file. So I'm going to go ahead and click the 3 dots, go back up a folder. This QSF file will be shared with you again. So just click Open and click OK. Now, if you see, the assignment editor has populated our design with various pins. So what we'd want to do is go back to our gates.bdf. I'm going to close this compilation report. I'm going to rename some of these so that we can use actual pins. So this is going to be named switch 0, switch 1, switch 2, and switch 3. Same goes for output. I'd like to use the LED red 0. Copy that. LED red 1, LED red 2, LED red, oops. LED red, oops, 3. There we go. And I will simply save and compile. I use the hotkeys. Yeah, enjoy the background music for a hot second while it's compiling. The compilation depends on your processor. So if you have a faster processor, the compilation time will be fairly slow. If you have an older processor, well, you're going to be sitting here for a while. But luckily, we don't have to wait too long. Great, now let's go back and check on our gates.bdf, and you will now see that it has added quite a few pin names. These pin names are equivalent to the actual FPGA. So what we're now going to do is hit save. Go ahead and click tools, scroll down to programmer, because we're going to now program our actual FPGA. Right now, if you see it says no hardware, that's because my FPGA is turned off. I'm gonna go ahead and turn it on. Probably heard that. And go click hardware setup. We'll now see DE-SoC, so double click that. So it's now the currently selected hardware, and click close. Now what I like to do is press auto detect and select this model right here, because that's our FPGA and our specific device that we want to program, and click OK. So it's going to say that it auto detected some changes. You're going to go ahead and say yes. Because DE-10 board is split into two parts, it has a HPS as well as the FPGA. So that's why you see this format right here. So now what we'd like to do is go ahead and click add file, go to output files, and select the .sof file, and click OK. Now if you see, I have 3 values right here, but the only one that's defaulted to program is this one right here, and has our actual FPGA model name. So I'm going to go ahead and click on this and just press delete. And now I will simply click start, and this should then upload the code to the FPGA. I'll probably leave that for you to actually test out. It should be the exact same output expectation as we would see with our functional simulation settings. And then I'll leave a truth table up down below as well. Well, that brings this to a close. Thanks for watching.